All right, welcome to 3.9, Interpreting Quadratic Models. Basically, this whole thing is on word problems. So you might want to just like kind of jot that down. This is kind of like quadratic models or word problems. Specifically, quadratic word problems, right? And the deal with word problems is that oftentimes they're going to use certain words or phrases, and we have to know what they're really asking about. And so I've created this chart, and this isn't by any means all of the possible phrases you might see, but it just should give you an idea of the different phrases you might see and help prepare yourself on how to solve certain problems. So this is just the first half of the video. The second half of the video is going to be a Khan Academy video, but for the first half, I just kind of want to go through this chart with you guys. All right. So if you hear something like certain keywords like the starting value or starting time or the height at the time of takeoff, right? All these ideas of where a certain thing was at the beginning, this is usually talking about the y-intercept. And this is something we've already learned how to solve for. This is when x equals 0. It's the c value when it's in standard form, right? It's just the c value. It's the y-intercept. Remember, we said that it's easiest to find the y-intercept if it's in standard form, and that makes sense because it's just this number all by itself. Okay, some keywords. So anything having to do with like where it is at the start or at the beginning, or the height of something at the beginning, that's going to be the y-intercept. All right, next. What about if it says something like it when it hits the ground, when it landed, a 0 or a root? This is the x-intercepts, and the reason for that, I'll kind of give you an idea here. So if I sketch the graph for this, typically if we're talking about a real-world problem, we're talking about some parabola that looks like that. If you imagine something flying through the air. Well, remember, here's the starting value, because if this is like time, and this is like height. Well, when time is 0, it's going to have some starting height, and usually the height it doesn't take off from the ground. It could take off from the ground and go up, but usually for like throwing a ball or something, it's going to start with a height of wherever our arm is or wherever our hand is. Then it goes up and it hits the ground, and you think about it, that's the 0, right? That's the x-axis. So that's when it hits the ground is like a 0 or an x-intercept. And we typically care about the positive one because if you think about this graph, it does kind of keep going and it has some negative 0. But when we're talking about a real-world problem, like a word problem, we're typically not going to care what's happening in negative time or negative space because we don't really think about that in the real world. But it does have some correlation to positive time or positive space. So we usually only care about this 0, the positive 0. So these are phrases you might see when it hits the ground, when it lands. Maybe they're just going to straight up ask for the 0 or the root. These are all just ways of asking for the x-intercept. And this is, again, when you set y equal to 0 or fx equal to 0. This is most easily found in factored form. Remember, it's the opposite of the values you get when you factor it using this. That should say star. Sorry, that should say star method, not start method. So you've also learned other ways. You don't have to factor it. You could also use the quadratic formula to find your zeros. You could also use completing the square. You could solve by taking the square root if it's set up in vertex form. There's a lot of different things that you can do here. That's what the whole first 4 chapters were all about, finding the zeros or the x-intercepts. So this is just kind of giving you some hints on the basic way to do it, right, to factor it, but there's a whole bunch of other ways that we learned. All right, next up, let's see, time when it reached the maximum min, location of maximum min, or when or where the max occurs. So this is 2 things here. I'm going to try and color code this. But if you think about your vertex, you have some h value, and you have some height that's your k value, right? And so you could have a point here. This h is for height, and this h is just your hk for your vertex. So you have some h, comma k point that's your vertex. Well, for example, in this graph, the h value is not actually the top. It's just the time it takes to get to the top. So when I say time when it reached the max or min, hey, that's your h value. And remember, we have a couple of different equations to use to find the h value. This is the most common. That's when it's in standard form. This one also works when it's in factored form. This is you just take your factors or your zeros. Sorry, your zeros actually. And you find the average of your two zeros. So that's how you get the h. But that's not actually the max itself. The max itself is this height. Or it could be a min, if this parabola is going opening upwards, we would have some bottom part down here. The max or min, this is the actual height. So this is the k value. So here's the h, here's the k. You're going to have to kind of distinguish between these two. And I think you'll get some ideas of the phrases used in this Khan Academy video. But I just kind of wanted to go over all those different things, how to find them. Oh yeah, real quick, remember, to find the k value, you just take whatever you got for h and you plug it into the function and it should kick out your k value. So those are really the four things that you're going to see a word problem ask for. They're going to give you some keywords that are really just asking for the y-intercept. They're going to give you some keywords that are really just asking for the x-intercepts. They're going to give you some keywords that are really just asking for the h value, or they're going to give you some keywords that are really just asking for the k value. So this little chart is really handy. In fact, on your quarter exam, I would definitely jot down some notes on a 3x5 card that correspond to this chart, because that would definitely help you on the quarter exam. All right, the next part of this video is a Khan video, so I'd encourage you to go ahead and move on to that.